Number 6, we have an airplane trip. There are 3 legs of the trip. So each leg is going to be represented by a vector. First leg is going to go due east for 610 kilometers. I'm going to draw that vector going straight east and label it 610 kilometers. Then the second leg will be southeast 45 degrees for 590 kilometers. So this angle here is a 45-degree angle, and the magnitude of this second vector is 590 kilometers. Then the third leg of the trip, we're going to go south of west 63 degrees for 650 kilometers. I'm going to label that angle on the south side of west 63 degrees. First part, what distance does the plane travel? So to find the distance, we're just going to add up the 3 distances. We're going to add up 610, 590, and 650. And we're getting a total of 1850 kilometers. Make sure that we have a unit. It's the same unit that's given to us in the problem. Part B, what is the plane's total displacement? That means from its first starting point to its last ending point. How far is it? So I'm drawing that vector in red. That's the resultant vector. We want to know what are the coordinates of the plane's ending point. So in order to find those coordinates, we're going to take all 3 vectors and we're going to add them up. So the first vector, because it's due east, it's going to be 610, 0. The second vector, it's going right and down. So it's going to have a positive x coordinate and a negative y coordinate because it's going down. And remember, the pattern is the magnitude times the cosine of the angle, and then the magnitude times the sine of the angle. And remember that y coordinate has to be negative. And then the last vector, same pattern. It's going left, so the x coordinate is negative. And the pattern is magnitude, cosine. And it's also going down, so magnitude, sine. It's negative because it's going down. So to find that final stopping point, we're going to add the horizontal components. That's the first number in each vector. We're going to add those 3. That'll tell us the x-coordinate. And then we'll add the 3 y's here in green. That'll tell us the final y-coordinate. So I'm going to my calculator and I'm typing. Obviously, you will get a calculator on this one, so ignore that part about no calculator. That was something that I wrote that I should not have. Okay, so I'm getting the x-coordinate is 732.1, and the y-coordinate, let me add those together. I'm getting negative 996.35. Now that we know the location of the ending point, we can find the displacement. It's the magnitude. So we're going to just calculate the magnitude of a vector that ends at 732.1, negative 996.35. So the magnitude, remember for that we're going to do the square root of the x quantity squared plus the y quantity squared. So I'm just putting this into my calculator. Just a moment here. Now I'm finding 1236.4. And the unit is kilometers. Okay, it does not ask for direction, it only asks for displacement. So we are done. Let's try number 7. Exact same problem. Still an airplane, still 3 legs, still 2 stopovers. All this changed here is the number, so we can go through this one pretty quickly. We are going to go due west for 410, southeast at 45 degrees for 150. Make sure you label that angle. And then south of east by 58 degrees for 340 kilometers. Okay, so the total distance, we're going to add those 3 magnitudes up. 410 plus 150 plus 340. And we get 900 kilometers. Now displacement, we have to know where is that endpoint. So we have to turn all 3 of these into vectors. So the first one, because we're going to due west, it will be negative 410, 0. The second one, we are going southeast, so it's positive x, negative y. Magnitude, cosine, the angle, magnitude, the cosine, the angle. Positive x, negative y, because we're in quadrant 4, we're going right and then down. Last vector, also right and down, so positive, negative, will be 340 cosine 58 and 340 sine 58. This one up here should be sine. Okay, always cosine, sine, x, y. All right, now let's add those x's, let's add those y's. We are going to our calculator. So adding up our x's, we're getting negative 123.76. That's the resultant. Negative 123.76. And then the y coordinate is negative 394.40. So then to find the displacement, we're finding the magnitude. So we're going to square those values, add them, take the square root of the whole thing. The magnitude will be the square root of those numbers squared. And again, going to the calculator to find that answer. And we're getting an answer here of 413.08 kilometers. That is the displacement. Okay, let's practice one more. Same scenario. I wonder what the scenario is going to be on the test. An airplane trip involves 3 legs and 2 stopovers. This time, first leg is due north for 140 kilometers. And then southwest, that is 140. And then southwest for 390. And then south of west again. So this first southwest angle is 45 degrees. Right there. That's a 45 degree angle. And then now we're going at a 42 degree angle. 42 degrees for 200 kilometers. Okay, so the distance is the total of 140 plus 390 plus 200. So we have a total distance of 730 kilometers. The displacement is how far is it from the starting point to the last ending point. So we're just going to add those 3 vectors together. We can only add vectors if we have their x and their y components. So we're going to rewrite them all with x and y components. First vector goes straight up, so 0, 140. Second vector, it goes left and down, so both x and y are negative. Magnitude, cosine of the angle, magnitude, sine of the angle. Same thing for the third vector, magnitude, cosine of the angle, magnitude, sine of the angle. You do have to know whether it's positive or negative. I'm getting that from the words south and west. West means negative in the x direction, south means negative in the y direction. Okay, so now we're going to add our x components here in green, and then we're going to add our y components here in blue. So we're getting an answer of negative 424.4 in the x direction and negative 269.6 in the y direction. So that tells us the location of that ending point. Now we want to find that magnitude, the distance of that red line, that red vector. So that's going to come from doing our Pythagorean theorem. So the magnitude is going to be the square root of the x-coordinate squared plus the y-coordinate squared. So we're going to go to our calculator. And we're getting that the magnitude here is 502.79 kilometers. So you have that in your